Okay, good morning. So let us, as usual, solve the homework problems first and then continue our lesson, okay? So the first question is if one solves this equation, sine, cosine 2x plus sine of pi over 2 plus x equals to 0, and specifies all the solutions as points on the unit circle, then these points are vertices of which one of these shapes? Yes? So in principle, you are supposed to solve this equation here, yes? Okay, so the question is cosine 2x plus sine pi over 2 plus x equals to 0. I'm not saying there is only one way to solve this, might be, have different way of solving this, but one way is to understand this combination and probably move it to the other side. Or if you move this to the other side, what will happen? It becomes minus sine. Okay, but one of them is cosine, the other one is minus sine. So you have to make it a standard. So you need equality between two sines or two cosines somehow, yes? So I don't know. Do you have any suggestion? Yes, sir?
Maybe writing sine of 90 minus 2x instead of cosine of 2x.
Yes, so that is one way, yes? But if you do that, then you move this to the other side, then what will happen? So let me follow what you said, okay? So you said instead of this one, I write what?
And 90 minus
90 here in radians, so let me write it two big, okay. And then I have another sign here. So what should I do? Move it to the other side. When I move it to the other side, what will happen? It becomes minus. This is very good, but except this nasty minus sign here. So I have to get rid of that in some way. So what is your suggestion for that? Because it's not standard, yes? Sign of box is not equal to sign of something else. It's negative of that. Yes, what should I do?
write sine of minus pi over 2 plus x.
Yeah, what you mean is to move minus inside. So minus inside goes for both this one and that one if you want to. Or if you want, you can multiply this by minus sign and switch these. Okay, so that's up to you, which one you prefer. Okay, so let me follow you, okay? So you told me, because there is a rule here, do you remember? Minus sine theta, if I want to, I can move this minus sign in. Yes, do you remember? This is the trigonometry of opposite angles. Okay, so what she's proposing is to move this minus sign in, but be careful, this minus sign goes for the whole angle, not just for the first part. So minus sign will go for this one, so it means minus sign should go, so it means that minus sign goes like this. Yes, and then when you multiply that minus sign, both of them become now negative. So yeah, so let us follow. So sine of pi over 2 minus 2x, and then I move the sign in, so it becomes, so I'm not saying this is the only way, you told me I'm following you, because it works, I think so, because everything is correct. Now we have this rule, yes, do you remember? If I have sine of a box equals to sine of the circle, what can I conclude about box and circle? Either they are equal, with a multiple, of course, 2 and pi, and then the other scenario is not 180 here. I have to write pi minus circle plus 2 and pi. So these are what we learned during the lesson, yes? So now what I do, I give the role of box, for example, to this, and I give the role of circle to this, and I use the formula. So what should I do? I would say that the box, I consider two cases. So either the box, yes, is equal to the circle plus 2n pi, but then it is very easy to solve. So let me just consider this, finish it, and then consider the other scenario. So what should I do? So let me see if I'm recording. Yes. Okay, so what should I do now? For example, I move minus x to the left, minus 2x plus x becomes minus x, then I move pi over 2 to the other side, so it becomes minus pi over 2, another minus pi over 2, which becomes minus pi. And then I have what? 2n pi. And then I multiply everything by minus sign because I want to isolate x. So this becomes pi minus 2n pi. Yes? So, but where is this point? Where are the... So 2n pi, it doesn't matter, by the way, minus 2n pi or plus 2n pi. If you positive or negative, they go different directions, but that is one full circle, yes? The whole point is that this is pi. So if I ask you, can you show me the point corresponding to these angles? How many points are there? There's only one, yes? So if I draw this unit circle, because I want you to understand, I hope that you are not confused because of this minus sign, yes? So this is one full round in positive or negative direction depending on the value I choose for n. Pi is here. So it means that all these angles, of course here I have to emphasize that n belongs to z, all these angles, there are infinitely many angles but only one single point for that, yes? That is one scenario. The second one that I haven't considered yet is this one. So I have to go here. This time, the box, which is pi over 2 minus 2x, is what? Pi minus, again, let me be careful here, yes? Yes, agree with me? The box is pi minus the circle plus, and then I move this minus sign in. It becomes plus pi over 2, and then plus x plus 2n pi. This pi over 2 and that pi over 2 are gone. I move x to the other side, it becomes minus 3x equals to pi plus 2n pi. I divide by minus 3, so it becomes minus 3 minus 2n pi over 3. Okay? And then I need to understand where are these points. Okay, where are these? If you choose, for example, n to be 0, yes, what happens? It becomes minus 60, for example, here. This is one of them. But you don't need to be worried. Every time you add something to n, how much you are adding to your angle? 120. Why? Because this is 2 pi over 3. 2 pi over 3 in degrees is 120. How can I do it fast? Instead of pi, you imagine 180 divided by 360 times by 2, 120. So this one is 120 degrees. When I add one unit to n, in either direction, or either I go in that direction or in the other direction, it doesn't matter. So I add 120 degrees to this. Here it was minus 60. Let me write it in degree, it is easier for us to understand. Okay, so that's minus 60. If I add 120, where I will end? At positive 60. So this gave me 2 new points, but the next one will be the same point. Because if I add 120 to here, I will not end up with a new point. I will end up with a point which was already covered from the previous answer. Okay? So it means that if I want to solve the problem, I can simply ignore this, because that one itself will take care of all the points. Okay? But here, the problem is different. They are asking you about, if I connect the vertices, if I connect these points, I will make a shape. And they are asking, what shape is that? Okay, so what shape is that? It is a triangle. So if I go back to this, of course it is also an isosceles triangle. That is not wrong. But if you have an isosceles triangle and an equilateral triangle, and then you are allowed to choose only one option, then you have to choose an equilateral triangle. Yes? So the answer to this question would be this one, not that one. Yes? Is that clear? Yes?
What does isosceles mean?
Isosceles means likbent in Swedish. Yes, likbent. Yeah, of course, if you have an equilateral triangle, it is automatically also an isosceles triangle, but not the other way around. Okay? So if I say this triangle is an isosceles triangle, I am not saying something wrong. But I can say more, especially if I have two options, and the options are these radio buttons, so you have to choose only one of them, then you should choose the more precise one. Yes, is that clear? Okay, so this is one of the problems that we are supposed to solve, so let me go to the next one. Yeah, might be this is a little bit unusual question, but let us see how we think about it together. So Ruben solves this equation and realizes that he can use only this formula to express each possible solution. He is right, so I'm telling you he is right, but he has to choose appropriate values for m. Which option does correctly represent all necessary values of m? Okay? So because I think they become relevant somehow. So is the question clear? So it means that if Ruben solves this problem, you can solve this problem and find different answers. But the point is that I want to see how many of you can combine those formulas that you get into formula like this. Okay? I just want to test your understanding not only on trigonometric equations, but what about we talked about that sometimes, for example, exactly like this. If it was in the test, if you write this one and that one together, of course it is not wrong. But if you want to summarize it and write it compactly, which one is enough? The right one enough, because it automatically covers the answers from the first one as well. Okay? So that is important to know for a higher level question. So let us do it together now. So question number two. The equation is this. So cosine 2x equals to sine x. I think you already know the idea, yes? So what should I do? Again, one cosine, one sine. So it is not a standard. So to turn it into a standard, I use this idea the same idea. So what should I write? For example, I don't know which one is better, so let us just stick with one of them. So cosine 2x is equal to, instead of this one, I can write cosine. And because of the question, you see the question is expressed in degrees. So it is telling us, okay, so let us solve the problem in degrees. So what should I write? I would write 90 degrees minus x, agree? And then do you remember the formula for cosine this time? We had cosine of box equals to cosine circle. What happens? The box is either plus or minus the circle, but plus n times 360 degrees. So that is the formula we learned during the lesson. So I give the roll of box to this, and I give the roll of circle to this. So what happens? 2x becomes equal. Be careful, you have to put plus or minus, not like this. There is a flaw if you write it like this. Yes? How should I write it to be correct? Yeah, I have to put a pair of brackets around. Now I consider two separate scenarios. One with positive sign and one with negative sign. So one with positive sign, so 2x is 90 minus x plus n times 360 degrees. So I move this to the other side. And then I divide by 3. Yes? That is one answer. And the other answer, I have to consider the negative sign. But remember, the negative sign goes for here and there. So it becomes minus 90 plus x plus n times 360 degrees. So if I move this to the other side, it directly gives me okay. So these are the formulas that I get for after solving the problem. But let me write the formula in the problem itself. M times 30 degrees, but this one is 360 degrees, yes? So x is m times 30 degrees plus n times 360 degrees. What is the idea? The idea is to see what are the points on the unit circle first, to see that how can I generate all of them using one single formula. So that's the idea. You agree? So this formula gives me some points. This formula might also give me some points. I need to consider all of them and then fine-tune this in a way that all of them will answer. Okay, so let us continue now. So I see that the solution of the problem is finished here. So you already know the solution for your equation. But the twist of the problem is you want to combine these two formulas into one formula of that type. Okay? So in order to do that, you need to have a good understanding where the points are on the unit circle. Yes? So where are the points? So let me just do them here. Yes, and you don't need to be very precise, okay? So this one is very simple. Where it is? Where is it?
270 degrees.
Yes, because this is just a full round, and then so what I care is just this angle, and that's minus 90. So this point is here. But how many points are they corresponding to?
3.
3. Yes, if I give 0, for example, it becomes 30. So let us say this is 30. Okay. And then every time I add 1 unit to n, again I go 120. So when I add 1, it becomes 150. So it becomes where? So 150, something like this, yes? And then what do I do when I add 120 more? It becomes exactly that point. Yes? Because that one is again 120. So this will generate 3 points. This generate 1 point, but this can take care of that one as well. Okay, so we have only these points. Okay, so this is what we have. We have to be able to generate 3 points from here. But the point is that they have put these 360 degrees, that is not under your control. As soon as you add 1 unit to n, you go 1 full round. So it is not possible to choose one value for m to generate for all 3. So how many choices you have to choose? How many choices you have to have for m to cover all 3? Because this is 360 degrees. So let us try to cover them one by one. To cover this point, what should I choose for m? 1. Yes? This will cover this point. To cover this point, do you remember what was the angle? The angle was 150. So what should I choose for m to cover 150?
150 by 3.
Yes, it should be 5. Yes? And then I will also want to cover for the last one. It is 270 degrees. So what should I choose? 9. So 1, 5, and 9 is enough. Of course, in your options, you also have 1, 9, 1, 5, 9, 13. Yes? But if you choose this is not wrong, it will also cover again. But this is not necessary. Yes? So you shouldn't get confused that which one should I choose. Of course, I agree with you. 1, 5, 9, 13 will also cover 3 of them and then 1 of them extra. But that is not necessary. So you have to exclude that. Is that clear? So which option we choose? We choose 1, 5, and 9. Okay? So finally, the last problem. Consider the following equation. 2 sine x squared equals to 3 cosine x. 2 points are specified on the unit circle by considering all solutions of this equation. In which quadrant or quadrants are the points located? So I have given you a hint here, but I don't know. This is important that for the exam, I don't consider this a hard problem. So this trick you need to remember yourself, even if it is not provided as a hint. I don't know if this hint is useful or not. Do you see how should you use that? Because my goal is to make this equation a standard. But because of this power of 2, none of the previous tricks work. Yes, so I have to find a different way. Okay, so what should I do? So let me write the problem here. So the problem is 2 sine x squared equals to what? Equals to 3 cosine x. So my idea was to tell you to use this formula that I mentioned. This is helpful because sine x squared plus cosine x squared is what? 1. From here, sine x squared can be written as 1 minus cosine x squared. What is the benefit? The benefit is at least instead of having a mixture of sine and cosine, I will have only cosine. Okay? So what will happen? So if I want to continue, I would write 2. Instead of sine x squared, I write 1 minus cosine x squared. And I have 3 cosine x. Okay, so I multiply 2 in. I hope that you know what is happening now, yes? So what type of equation is this? You can use, for example, an auxiliary variable or introduce a variable in. So I would say, it is not necessary, but it is good to write. For example, cosine x, I call it t. Yes? Then what happens to your equation? Your equation becomes simply 2 minus 2t squared is equal to 3t. And that's an E-level question in Math 2C. You are supposed to solve this quadratic equation. So let me move everything to the right. This becomes 2t squared. This is plus 3t. And then I move 2. It's minus 2 equals to. And I prefer to use ABC formula for finding t. So t becomes minus b plus or minus a square root of b squared 9 minus 4 times this times that, which is positive 16. And then divided by 2 times this number, which is 4. And this is 25, 5. So it's minus 3 plus or minus 5 divided by 4. And then I have 2 answers for t. One of them is minus 3 minus 5 is minus 8 divided by 4 is minus 2. The other number is minus 3 plus 5, 2 divided by 4 is 1 half. Okay? If this is the case, I am not looking for t, I am looking for little x. So from here and this, I understand that cosine x should be minus 2, but not acceptable, because cosine x cannot be lower than minus 1. So no solutions from here. But this one gives you what? Cosine x equals to 1 half. And 1 half is a famous number. It's 60 degrees. It hasn't mentioned in which units work, so we can work in degrees. So x becomes what? Plus or minus cosine inverse of 1 half, which is plus or minus 60 degrees plus n times 360 degrees. Okay? So this n times 360 degrees is one full round. So what matters for you to find the points are these two numbers. One of them is positive 60. Definitely it is in the first quadrant. And the other one is minus 60. It is definitely in the fourth quadrant. Yes? So which one we should choose? Yeah, one in the first and one in the fourth quadrant. And that's the answer to this problem. Any questions? Okay. So that was a little bit unfortunate. You know what happened? I didn't record this last part. Anyway. Anyway, so I don't know what to do. Okay, I will do it later myself. That is the trouble that people make.